see your student.
Thanks.
So how many students you have right
This
now?
class I have, I should say, 12. The other class, I asked them, they have some overlap.
Okay.
Right now, they have a class with the other teachers. I asked them to join us for.
Okay, that's great.
I said that I'm going to talk to your students, but if you don't mind, can I just record the session? Then I give it to the whole school then.
Yeah, no problem.
That the other students that cannot join us, they can also see that.
Sure.
Awesome, thanks. How's your day so far?
So far so good. Just quite busy with the marking the end, wrapping up, the term.
Oh, that's right. That's staying home. Okay, let me see.
Everybody should stay home.
That's so true. Guys, please have your cameras on. Normally, we do not have the camera on. They feel a little bit shy.
I know. My daughter feels the same way too. Hello.
Hi.
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 So is everybody at their home, right?
That's right. They finished their school, I should say, maybe over a month and a half ago.
Oh, okay.
They are very sharp students. They are normally working on very advanced materials. For example, Sean, Ningje, Arya, everyone. Just actually, right now we were talking about the Gibbs phenomenon
really? Right. That's my favorite. You're talking about Fourier transform?
That's right.
Oh, okay. That is one of my favorite topic. I use Fourier transforms a lot.
That's right. And I asked them to do some kind of, right now they have three projects in hand.
Okay.
One of them is for both of my classes, actually. One of them, which is due very recently, they're just going to do some kind of mathematical modeling, I should say, for, I forgot it myself. There are lots of projects. The one which is very recent is they're working on the Hodgson-Huxley model for that's right, for the action potential of the brain.
Okay.
The other one they are just working on is mathematical modeling for bacterial mitosis. Okay. And also the applications of the radioactive decay in the cancer therapy.
That's perfect. Yeah.
That's right.
How about, I'm going to talk about the math modeling contest that is ongoing. It's a nationwide. I think it's a great opportunity to take a real challenge.
That's
so
right.
Those math modeling problem is a real problem. It's not like a textbook problem.
That's
and then
fantastic.
The solutions to the problem is open-ended.
That's right.
Yeah, that's why
right. I should say I have enrolled students into the contest. Rose, for example, Rose joined us today. Hi, Rose.
Hello.
Hello, Rose.
Rose,
That's a cute cartoon. Yeah.
Yeah, they are in the contest now. They are waiting for the contest to start.
Oh, okay.
And they also asked the principal to join us. He said that he's on a teleconference. We have an inspector coming to do the inspection. He's joined us in the middle of the session. And
okay,
yeah,
that's fine. Yeah.
And I see most of the people are present now. Let's see. I can see, guys, some of your cams are off. Guys, everyone says hi to Professor Zhu.
Good morning. Good morning.
Hello.
Awesome. Awesome. Guys, do you want to introduce yourself quickly to Professor Zhu? Say your name. If you want, you can speak some words in Chinese, if you feel more comfortable.
Yeah, and I speak Chinese too.
Yeah, say anything you want. Introduce yourself very quickly. Say your names and do some greetings.
How about introduce yourself, like which grade you are, and also which province that you came from, which province in China that you came from. And I'll see if anybody actually came from the same province as I do. So how about I'll introduce myself?
Uh-huh.
I'll start with, so I'm Hong Mei and a professor at the Department of Math and Stats at York University. And my research area are in, data science and machine learning AI applications with industries, and also lots of math.
Internet.
Hello.
So
Yeah.
the
Oh, sorry,
internet.
just
So,
got disconnected.
my internet was just interrupt.
Yeah.
Everybody hear me?
Yes, I can
So
hear
the
you now.
background of my photo actually is my favorite part in York. Can you see it? The beautiful building actually belongs to the engineering. Too bad it now belongs to math. But I really like the surface of this building because it represents one of the mathematical numerical method in math to calculate, the differential equations. So, it covers with all the triangles. So anyhow, so I graduated in China, Shandong University in 1994, and then moved to University of Waterloo and received my PhD. And after that, I spent 3 years in Calgary, actually working in the hospital with the medical doctors doing medical image processing. And then finally, I ended up with a job at York and started to do teaching as well as, continue my research. So that is basically, my whole path. So is anybody here from Shandong?
Yes, I'm from Shandong, Qingdao.
Oh, Qingdao. Okay, I'm
exactly.
from Jinan.
Oh,
Yeah, Qingdao is a
we are in the
beautiful.
same province. We came from
Yeah,
the same.
yes. Qingdao is a beautiful city. I visited last year. It's so beautiful.
Yeah, I miss the seafood a lot.
I was born in Nanjing, Jiangsu province. Anybody from there? No? So how about you introduce yourself and let me know more about you. Mingxi, do you want to start?
My name is Ningxi and I'm 70 years old. I came from Hebei province, China.
Okay.
Currently, I'm a grade 12 student.
Mm-hmm.
I'm-
So do
yeah,
you, are you applying for a university?
yes, I'm applying for Centennial College.
Okay. So what is your major?
I'm going to study the aircraft maintenance.
Okay, cool. Yeah, engineering. Right?
Yeah. Just,
Okay, you must like airplane.
yeah.
Okay, Brian.
Well, I'm Brian, and I was born in Shandong also.
Which province? I didn't hear.
Shandong,
Oh, Shandong, which city?
yeah, small city called Rizhao.
Oh, Rizhao. I love the green tea from Rizhao. That's one of my favorite green tea. That's my
Yeah.
only green tea to go. Rizhao green tea is very good. Yeah.
And I think that's it, maybe. No more information.
Which grade are you in?
Secret.
Secret. Okay.
Yeah.
We'll keep it secret. Okay.
Yeah,
Hello.
okay.
I think the internet was not stable.
Yeah.
Thank you, Brian. Sean, do you want to introduce yourself?
Yes. Good morning. My name is Sean. I came from Shandong province, and today is my great honor to listen to your speech. I'm so excited to waiting for it.
Same
So
to you. Same to me
yeah,
as well.
I'm a grade 11 student, studying in Berkshire Academic Institution. I'm interested in mathematics and physics. As I started with OMID last semester, I did I did something about the two photon fluorescent microscopy, and we did a presentation, and we visited to University of Toronto Imaging Center to see the microscopy. Yeah, and I also learned some researches from OMID, like today's Gibbs phenomenon and signal processing. They
Okay,
there are
cool.
something about the fluorescent. There's something about the Fourier transform. So yeah, that's probably all this.
Yeah, I'm not sure how about your internet. Like sometimes I'm
Unstable?
losing your word. You know, the
Oh,
internet is not stable. Yeah,
maybe.
yeah, but it's great to know that you already started to, you know, have some research experience in different
right.
area. You know, I do signal processing too, and that's why I said Fourier transform and you know, those things that we use a lot. Yeah. All right. Thank you, Sean. Aria,
Yes.
I only see the ice bra.
Oh, sorry.
Here, you look beautiful.
Thank you.
Shy.
Good morning, teacher. My name is Aria, and I'm 19 years old now. I
Mhm.
come from Tianjin.
Tianjin, yeah.
Yes.
Like Tianjin 煎饼果子, right?
Yes.
Yeah, it's my favorite.
It's delicious. And I'm grade 12 now, and I'm waiting the York University's offer.
Oh, which university?
York.
Oh, okay. Which department are you going to?
And my favorite major is management, the human resources.
Okay, excellent. Yeah,
And that's all.
congratulations.
Thank you.
Yeah,
I'm waiting.
great. Thank you, Aria. David, I see you're hiding.
Yes.
Hello,
teacher.
David.
Yeah.
Yeah, can you just pick your head? Yeah, hi.
Hi. Hello, teacher. I'm David. I'm from Jiangsu.
Okay. You know what? I was born in Jiangsu. You know, Nanjing was the city that I grew up.
Yeah.
Yeah. Which city in Jiangsu did you come from?
English is not good.
It's okay. 你江苏哪个市过来的呀？哪个地方过来的？
泰州。
泰州. Okay, that's great. So when did you come to Canada?
Okay. 什么时候呢？
Long time ago.
And I 怎么说呢？我也不太会说 ，sorry.
It's okay. Yeah. So which grade are you in right now?
Sorry, teacher. What?
Sorry, I think my internet is not. Yeah. Sorry. Well, David, which grade are you in?
I want to go to everything university.
Okay, okay, that's great. So you like to
Um,
be in the medical field, right?
Yeah.
Okay, excellent.
mm,
Yeah. Okay, so who else? Olivia? Hello, Olivia.
It's Oliver, not Olivia.
Oh, Oliver. Sorry, I see.
Yeah, sorry, I don't have a camera on my computer.
That's fine. That's fine. Yeah.
So I'm Oliver from Xinjiang province, grade 12
Okay.
students, studying advanced function for now. And I'm looking forward to apply mechanical engineering for university.
Mm-hmm.
Yes, that's it, I see.
I see. So you're grade 11?
Yes, for now.
Okay. And which majors are you do you want to apply?
I want to apply mechanical engineering.
Okay, I see. Yeah, that's good to know. Because before, I talked to Omid, I thought all of you wants to do finance. So it's great to know that you have, different interests, and then, you will go for different, career. So I'll try to mention that. Yeah. Okay. Thank you, Oliver. Oliver, right? Rose.
Yes, hi.
Hello, Rose.
Hi. Good morning.
Hi. Good morning. Let me guess. Do you like Japanese animation?
Yes, a little bit.
My daughter does that too. She's 12.
Oh,
Nice.
She just turned 13. Yeah.
so should I introduce myself?
Yes.
Hi, I'm Rose. I am from Hebei province, and I'm in grade 11 now.
Okay. I'm losing you, Rose. You're in grade 11.
Yes, I'm in
Yeah.
grade 11 now.
And what is your interest for? Yeah. And what is your interest? Do you have a plan for university?
I haven't decided. Oh, maybe commerce or something. I'm not sure.
Commerce.
Yes.
Sorry, it's commerce, like something related to finance.
Yes.
Okay. Okay, I see. Yeah. Thank you. So, I didn't mention that actually I'm the financial engineering coordinator at York. So we have a financial engineering program. It's a master program at York. So I'm also teaching computational finance as well. All right. Yeah. All right. Thank you so much for
We have one person
giving me.
left, Professor. It's Linda.
Oh, Linda.
Sorry.
Linda, I just saw Linda. Hello, Linda.
Hi, teacher. My name is Linda. I come to Guangdong.
Okay, Guangdong. My husband actually came from Guangdong. So we're all kind of connected. Yes?
Yeah,
And which grade are you in?
11.
Grade 11. And what is your interest? Like, which subjects do you like the most?
Music.
Music. Cool.
Yeah.
Math, there's lots of math in music too. All right. Okay. So I'm so glad to know anybody. Actually, I prepared a presentation, but after hearing your, you know, your interest, can we go something like this? I'll give you a presentation. How many times I have up to 11, right? Yeah, so how about I give you a 10 minutes presentation and I leave another 10 minutes for you to ask me, then we'll interact with each other. How's that?
Fantastic.
Okay, good. So can I share the, you know, my presentation?
By all means.
Yeah, okay. So I'm going to share, you know, it's probably more than, you know, takes more than 10 minutes to go over it, but I'll just, you know, briefly introduce what it is. So I would like to talk to you about modeling, because I think modeling covers a broad applications of mathematics, and it can give you some sort of sense that mathematics can take you. Okay. So first of all, like when we talk about math modeling, you know, people probably, you know, don't know what is math modeling is. It's basically use math to solve a real problem. So we basically use mathematics, like either mathematics equations or mathematical language or logics to represent, analyze, and to make predictions about a real world you know, problem. Okay, so why, you know, why we are, you know, why math modeling actually is very important. Right now, does everybody aware the COVID-19 crisis, right? Yeah, and does everybody know that the government actually give us, you know, the suggestions according to the math model that they have? Okay, so they study how the disease, you know, passes from one person to the other, and then they kind of mimic, you know, what interventions they should implant, and what is the effect of, say, the strategy like wearing the face mask or wash hand or social distancing has the effect to slow down the spread of the disease. So underneath, there's a math differential equation involved, and it's try to use the language of mathematics to mimic how the you know, disease is spreading among the society in the world. And then they simulate, you know, what is the worst scenario and what is the best scenario, use a different strategy, and then which will provide some insight to the government to make their decisions. Okay, so that is one great examples of, you know, mathematics. So quite often there are lots of questions that we want to ask, like what happened in the past, right? Or what could happen in the future, and what could we do to avoid disasters in the future? So all those things has not happened yet, or has happened, but we have little information about. So then, you know, use mathematics to extract the model and then to simulate what could happen, you know, in the future, or what could happen in the past, you know, give us some ideas to understanding the world around us, and also help us to plan for future changes. So that's why math modeling is very important. I treat math modeling as a real problem solving skill. Okay. So for instance, here has a table of the CO2 level in the atmosphere. So from 1980 to 2008. So here are the number that we collected. So from those numbers that we collected, we want to ask, what is the CO2 level, in 2050, okay, when you guys grow up, right, 2030. And then how do we prevent the increasing CO2 level and so on. So from this table, what we can see obviously is the CO2 level is increasing or decreasing from 1980 to 2008. It's certainly increasing, right? It starts from 338.7, and then in 2008 is 385.6, right? So it's certainly increasing. So looking at the numbers like this way may not give us a direct impression on how the CO2 level changes over time. So sometimes our approach is we visualize the data differently, okay? So we plot them and then we look at the patterns and then we see how this pattern can fit into a mathematical curve, and then we can use this curve to predict the future, okay? And so if I, put those data on the plot, x-axis is a year, and then y-axis is the CO2 level, in the atmosphere. So then we see that clearly those dots is approximately has a linear trend, right? Okay, then you see that I can find the slope of this linear trend, and I can draw this a linear curve that fits most of the data perfectly. That means, I can find this linear line that has the minimum error that, between all the data points, okay? So once you have this model and you think it's reasonable, then you can just have the theoretical expression of this linear line. And then you can predict what is the CO2 level at 2020 is now 2030, right? 10 years later and so on. And then you can also, play the strategy. What if we reduce the number of cars on the street? We can reduce the, how the factory should, factory and so on, okay? So that's all those things that can help us what could happen in the future, and if we interfere, implement some strategies to reduce the CO2 level in the atmosphere, and then how we do it and so on. Okay, so from this too, we can answer lots of questions. All right, so the mass modeling actually can, is everywhere, okay? So the first example on the top left corner, it just shows the how infectious disease is spreading among people, right? So that's why at, this COVID-19 outbreaks, now the doctors suggest people to wear a face mask, which we already know when the outbreak happened in China, right? But it takes Canada some time to actually recognize that. So if they can recognize that earlier, then we won't be trapped at home for so long. And also it can study other type of CO2, the three-dimensional. So the previous model is one-dimensional, and now it's a three-dimensional model for the CO2 model, CO2 level in the atmosphere, and then other interact with the winds and solar radiations and other more complicated factors. Okay, and also you can study the social phenomenon as well. How the how does the influence of one hockey team can be spread socially. Like here, everybody likes Maple Leaf, right? And if you're a newcomer, like you guys just came to Canada, came to Toronto, how you were affected by other people's passionate about hockey, and then that passion passes to you, and you become a Maple Leaf fan and so on. So this is a kind of use a similar strategy that used to study the infectious disease model, and you can also use that to study the social phenomenon. And of course, when you like roles, right? Roles like finance. So for finance, one of the big things is investment, right? How do you do the investment to reduce your risk? And then you can use mathematical model to model how the stock moves, right? How the financial product on the stock, the price changes. And then from that, you can come up with different trading strategies to reduce the potential market risk from against the loss and so on. So there are many things. And also, sorry, I didn't remember how your name. Let me see. Ming Xi, right? Ming Xi.
Yes.
Yeah, you like airplane, right? So when
yes.
the airplane is fly in the air, right? One big problem is the wing is such a long and a thin structure, and it's easily vibrate in the when in the air, right? So big vibration will cause the damage to the airplane, and which we don't really want that to happen. So then they actually use a control theory. They use the differential equations to model how the airplane winds vibrate. And then you put some other devices to stop the vibration in the airplane wings, okay? And also the design of the shape of the airplane is also a quite large mathematical model. And then usually they have to use a math model to simulate, the shape of the airplane. How does that interact with airflow and so on, Yeah. So, all this has a very meaningful, all has math component in it. All right, so, and also the, I think, who is interested in mechanic engineering? David, right?
I think Oliver also.
Oliver. Yeah, Oliver is interested in mechanical engineering, right? So for mechanical engineering, when you build, like in downtown, there are lots of high-rise buildings, right? So at the top tip of the high-rise building, we know that it's not steady. Actually, the tip of the high-rise building, they are swing in the wing, right? So therefore, they have to study all those vibrations. They have to study how strong this building can stand for the wings on the top to stop that, and also the vibration of the bridge. Actually, my PhD supervisor, he actually was a civil engineer. So he is always interested in the vibrations in the mechanical buildings, like, mechanical structures. So all those, has, to solve those problems professionally, you need certain type of mathematics to help you. So mathematics, the way that I view it, as a set of tools, right? The handyman tools in the bucket. So it depends on the problem that you want to solve, and you just select the right tool to solve the right problems. Okay, all right. And then there's a book called The Introduction to Mathematical Modeling, and that is a very good book to read to see where all those mathematical modeling can be used. And I think the targeted readers are high school students in general. Okay. All right, so as we see, the math modeling is really the bridge between your school mathematics or classroom mathematics to the real world problem solving, okay? So it's kind of a bridge then, and then let you realize that math is not only as a tool to solve a textbook problem, but it's actually a tool and a language that can be used, very useful to solve a real world problem. So here, to let our Canadian high school student to realize that, to have more exposures to math modeling, we I lead a team at York, actually promote a national math modeling contest. So it's targeted to grade 9 and 12 student either in public or private school, and test. And then simply one word problem, no math equation at all. We just explain the problem in word. And you could have a team up to 4 students. This example, Omid, you can.
Professor Zhu, I think there is a problem with the connection. Hello? Hello? Hello?
Hi, teacher.
That's
are you there?
brilliant.
You can hear me, huh?
We can hear you, but
That
I
was
can't
so good.
hear
I
the.
think you lost the connection to Professor. I
Yes.
should
The
say.
connection
Hi,
was
Professor
not
Zhu.
stable.
Sorry, I think you lost connection to you when you just started to talk about the format of the competition.
That's right. Yeah. So basically, you know, the format is a one word problem, and you can team up to 4 students and register by one teacher. One teacher can register multiple teams from your school, and each team has a maximum 4 students. And it can be mixed grade, can be grade 9, grade 10, 11, 12, depends on the skills. And each team will have consecutive 5 days to work on that. And now because of COVID-19 outbreak, we extend the end of the contest to the May 12th. Okay, and you can use any books, any software that you can find online and to solve it, but then you have to reference it. Okay, and the teacher don't have to monitor you 24 hours. The teacher's rule is just to help you register and make sure that you fill out the parents' authorization form and so on, and then submit your solution in the end. And you guys going to work as a team and to solve the problem your own. Okay, so in the end, what you submit is a lesson, a page, a summary, and a full report. And we will have the national round of competition first, and from which we have a number of awards given to our national team. And then the top 2 national team will be forwarded to the international contest level. And then I want to say that this is a well-recognized math modeling contest worldwide. Okay, so last year we have a 52 from 27 countries. And once you put this experience in the resume for when you're applying for university or applying for the job, people know what it is, and then they really appreciate that you take the challenges and then to be able to apply that to solve a real problem. So whether you receive an award or not, it itself is already a credit to you, okay, especially for high school students. And for your, okay, so I highly recommend you to apply for that. So in the past, our best international award that we get is the 3rd level for the Canadian students.
Oh, that's nice.
Yeah.
Professor, when is the date for the competition? What time, what date?
We have a period open because each school has your own schedule. So from this period, open period, you just select 5 days, see you cross a weekend, right? Where the student has less homework, competition time. So once you register for them and you download the problem, and then the clock on the website started to ticking, count for 5 consecutive days. So within this 5 days you submit.
I have registered the students for the competition. Then it's up to me now what time I upload.
When to click the download the problem. The problem is already up there. Once you download it, it's starting, start the competition for the students.
And when is the deadline? When is the deadline to upload the questions and submit it after 5?
Once you click, say you click today at 5 o'clock, then the start at 5. And then, so today is a Thursday, right? So Thursday, Fridays, so Monday, 5 o'clock, right? It's 5 days.
That's right. That's right. And
Yeah.
how much
No,
time do we
no,
have
no.
to?
Sorry, Tuesday, 5 o'clock. Before Tuesday, 5 o'clock, you submit your solution.
That's right. How much time do we have to enter the competition?
It's as long as to the, enter is 5 days before the end of this contest.
And what is the date for the end of the contest?
Yeah, so that now we extended, extended the hour. Just let me see. May 12th is the last day to submit your solution.
May
So then
12th.
you have to be minus 5, right?
That's right. Because we have the team now, and the team is assembled now. We are looking. Then we should look for the best date.
Yeah. So usually across the weekend is a good choice.
That's right. That's right. That's so true.
Yeah. Yeah.
So
okay.
True.
All right. So what you need is a teacher, nice teacher like Omid to help you register the.
That's so cool.
Yeah, register the game, and you have 4 good, buddies to work with. And usually a good team composition is 1 good at computer programming, 1 good at writing, 1 good at mathematics, like, understanding the mathematics. And then the other one is kind of overlapping with any of other skills. And then 4 of you, should be able to open to each other and work with each other. Okay. So, so basically, and also now, I'm not sure if your parents are here, but if you don't, you should find sufficient food to supply you for the 5 days. And then at 5 days, at the end of the 5 days, the user submit the summary and no more than 20-page report to Omid to submit it online. So that's basically what it is. And then we'll tell you the result once the result is out. And then, yeah, so the teacher's rule is just help to register the team, prepare the team, just guide the team. There's a web link where the team can look at the past problem and solutions. And I can send you the samples of the winning paper in the past, Omid, so that they can have a sense how to organize their report.
Oh, that's great.
Yeah.
Much appreciated.
And then teach them the math modeling process actually is very easy, which I'm going to talk about that, and let them have fun during the contest.
That's so
okay. So the basically approach to any type usually is a problem that you don't know. Okay. And we go with the 4th step of planning. First is to understand the problem before you do anything, okay? Read the problem and find out what they are asking, and then find out, discuss, doing internet search to find out what are the factors that will affect your answer. And then from all those list of factors, you want to make assumptions and reduce those factors into a small bucket of factors, the key factors, right? And then from that, you try to make the math connection have a working plan, how you're going to solve it, okay? And then once you try to solve it, and you will find that you may have to change your plan, and also you have to double check whether your solution actually makes sense or not. And then try to interpret and then check your solution, and then to have some conclusion from your, the analysis and so on. Okay, and I'll send you the a more detailed copies of the mathematical modeling process to you later. Okay, I'll send it to Omid, to your teacher, and then you can pass it to them.
By all means,
yeah.
Professor.
Yeah. So the past problem, it has how do you schedule, like when you're a director of the movie, right? There are different tasks to making the movie. How do you optimize the sources, to minimize the cost of making a movie? And also like insurance, right? When you're running, organize a contest, if the winner actually breaks the world record, you're going to pay a big check to them. But the organizer doesn't have the money to pay them check, right? So what they do is they can buy the insurance. The insurance ensures that if the world record is breaking, and then then the insurance company will pay the winner the check. Then the problem, how do you price such product? And whether, as the organizer looking at the list of participants, can you predict whether the record can be broken or not, right? And then from which you can determine whether you should buy this insurance or not. Okay, and then the other year's problem is if you organize an international meeting, how do you choose the time and the place for this conference so that when people comes in for the meeting, they don't feel sleepy at all, like they don't all fall asleep. So you try to maximize the productivity and minimize the jet lag among the people.
That's right.
And also, yeah, and also how do you choose the best hospital? And then last year, the problem is about the environment, right? How many people, how large the population our Earth can support, okay? So those are type of, problem that we have. So those are the, you can find the population data, and from the population data, one can easily see that the exponential model fits the data, right? So once you determine it as exponential model, then you have to, the coefficient for this exponential functions and so on. Okay, and then you can go from there. Okay, and then you also talk whether this model makes sense. This exponential model actually, sorry, let me go back to this one. Does not make sense because it means that as time passes by, right, we can feed at as much people as possible, but we know that the source on the resources on the Earth is limited. We only can support that much of population, right? So then this model is not ideal. Then we have to change it. So that is kind of go back and revise your model. So then you can find other models that to support that. All right. And tied to that, we also have a Math for Real program that to help to increase the education, math modeling education for high school teachers as well as a high school student. So we, we have teachers workshop, depends how many teachers are interested. And we also have a summer, we plan to have a March camp, but March camp was canceled due to the lockdown. And so we plan to have an online summer camp. So if any of you are interested, let me know, then I'll reserve a space for you. Then we'll have professor actually teach you the different topics, in the math modeling. So this year we plan to study the infectious disease model because that is kind of the hot topic right now, right? And also some other population model as well. So if you're interested in the summer camp, is probably in July. Let me know, then I'll reserve some space.
Fantastic.
All right, so then we have lots of high school teachers and professors and graduate students that are interested. Omid probably recognize some of them, right?
That's right.
And we also supported by different societies in Canada as well. Thank you. The whole PowerPoint, actually, I include how to solve PowerPoint to Omid. So Omid has a copy and he can pass it to you.
By all means.
And it's a little bit rushed because it's a huge topic. Yeah.
But,
all right. So do you have any questions for me? Sean, you definitely will be there, right?
Yes. Yeah,
yeah, he's on
I'm
the team.
interested in it.
Yeah.
Yeah.
So I prepared a image processing problem, but I don't have time to show them. Maybe next time.
By all means,
No problem.
I should say, Professor, today was the best day of my teaching experience because of you in the class.
You're welcome. Thank you for having me. It's nice to
Oh.
talking to you guys.
Thanks a million. The best day of my life ever. Thanks.
Thank you.
Thanks.
Yeah, thank you. So, Omid, if you have any problem regarding to the contest, let me know.
By all means, by all means.
Okay, yeah.
Professor,
And I hope to see some of you there in the contest. And we usually we have a award ceremony, but this year we'll see what's going to happen. Okay.
That's right.
Yeah, and I hope to see you at the award ceremony too. We have a nice medal and a plaques, for school and the winners.
That's right.
All right.
Fantastic. Thanks a million, Professor. I think the students are going to go to the other period class which they have. And if anybody has a question, very quickly ask Professor, I should say Professor Zhu. Nobody has a question? Then if you get any question, ask me, then I ask you a question to Professor Zhu then, if you're rushing for your next class then. Yeah, I think Professor Zhu, thanks a million, honestly. As I said, today was the best day of my teaching experience. I do not know how to thank you enough.
Oh, you're welcome. And thank you so much for having me.
Thank you for your time. Thanks a million.
Nice
And I
talking
stay
to
in
you
touch
guys.
with you then, Professor.
Yeah, the best luck for your study and
Thanks.
stay safe.
Thanks.
Yeah,
You too.
bye.
In touch with you then. Thanks,
Yeah,
Professor.
bye.
Thank you.
Have a nice day.
Bye. Thank
Bye.
you.
Thank you.
Bye.
Bye.
Bye. Bye. Thanks, guys. Thanks for everything. And I see you all then tomorrow. Thanks for staying too long. It was a wonderful session. Thanks for showing up for the lectures. And I see you tomorrow. We talk more about the thing which happened today then. Enjoy the rest of the day and see you all tomorrow.
Bye, teacher.
Thanks.
Have
Bye,
a good
everyone.
day.
Bye. See
Goodbye.
you.
See you.
See you later.